So in this video, we're gonna go over the Eakins microscope. In the previous video, we assembled this microscope along with the Amscope articulating arm. Hey, how are you?
I have a problem with my phone.
What
doesn't register touch?
is it the 6 Plus? 6S
Alright.
Plus. All right, that's it. Thank you. So in this video, we're gonna go over the Eakins microscope. We're gonna review the Eakins microscope. In the previous video, we unboxed the microscope and we also unboxed the Amscope articulating arm. If you've seen the previous video, we had the Amscope arm assembled on this desk, and I told you that we're gonna assemble it on the other desk, which is right over here. You see how this articulating arm is assembled on this bench and not on this one. The reason for that is if we are working on this desk and there's any shake on the desk, we do not want the arm to shake, because if the arm shakes, then the microscope is going to shake and we're not going to have a stable or steady image. So by attaching the articulating arm to the other desk, this one here, we're not going to have any shaky image. That being out of the way, the other problem we had was the adapter. When we unboxed the microscope, we assembled the stand and we wanted to attach the microscope onto the actual stand, we had to have an adapter. And the adapter did not fit properly. So let me show you what I mean. So this is the microscope here. If we did not have an adapter, then the microscope will not go in. So we had to buy an adapter. But if you notice, the lens is not going all the way in. So we got the wrong size. We should have 76 millimeters on the outer diameter and 50 millimeters on the inner diameter. So this is 76 millimeters. We put this in, it fits. But the inner diameter is 49.5 and the lens is 50. So that half millimeter is preventing the lens from going in. When we ordered this from Amscope, we thought that 0.5 millimeter is not going to be a big deal, but the lens is not going in. We do not want to force it in, and even if we did, the lens is not going to fit inside the adapter. So on that very same day, I looked for another adapter, and we got one that's 76 millimeters by 50. It's not from Amscope because Amscope does not have that size. And it arrived today. Let's go ahead and assemble it. Let's remove the Amscope adapter, and hopefully this one will work out fine. So far so good. Let's tighten it from here, and hopefully it goes in without any issues. And yes, it goes in. So we have the right adapter now. Perfect. I'm very happy.
Sorry, I don't know if I'm calling at the right time.
Yeah, no, it's the right time.
Is it right time?
Yes, yeah.
So I just saw your video on YouTube. It's pretty amazing about the...
Hello, how are you?
Good, thanks.
All right.
I want to see about getting this fixed.
What's wrong with it?
Cracking the glass and...
All right, and so the other thing that we got is the Amscope 96 LED shadow-free ring light that we have attached down on the lens. What's special about this ring light is it's shadow-free. Shadow-free means if you look at the LEDs in here, you can see that the LEDs are pointed in a 5-degree angle or maybe 7-degree angle. I do not know what angle they're pointed at, but there's a purpose why these LEDs are pointed at an angle. Now, if we have the ring light mounted down on the lens, laws of physics, a light that shines down at an angle will exit at an angle. So if we have a light shining down on the board, it's lighting up the board. What happens is that light is not going to bounce back to the lens. It's not going to create a flare. Let's say we have a light shining down on the board. That light that's shining down on the board is going to bounce back up to the lens. That creates flare, glare, reflections, so on and so forth. So if you're working on a board, you have flux on the board, and then you're starting to do some work, you will notice that you have a lot of reflections. The image is not clear. And that's because the light is shining down and then back up to the lens itself. So when you have the light shines down at an angle, it's going to exit at an angle and it's not going to bounce back to the lens. So you see a very clear image, as I will show you shortly when we start to inspect some boards under the microscope. The other thing that we have is the spotlight. We've had this for the longest time, maybe 5 years. What we can do is we can position the gooseneck, the spotlight, you know, maybe we want to do just one of them, maybe we want to do 2 of them, shine 2 of them on the board. What this will do is fill out the shadows that's on the board. Let's say we have a very clear image, but we still have some shadows on the side of the component. Maybe one component is a little bit higher than the other component. The height of the component can create a shadow. With these lights shining sideways, we can see a brighter picture, a better image, and we can adjust these goosenecks any way, shape, or form to get the light that we want. I will also show you how the gooseneck light works and how the image is like with and without it. So having said all that, let's get down to the microscope and see how it works. Let me grab a few motherboards here. Let's start with Samsung motherboard. And I'm gonna go ahead and turn the ring light on. And let's put a Samsung motherboard under the scope. And look at that. Look at that. Look at the image. Absolutely amazing. Amazing image. So crisp, you can see everything. I have the microscope on autofocus. Now there's a misconception on autofocus. Anybody who has autofocus will tell you turn autofocus off because autofocus is not going to be able to focus properly or it's going to bother you while doing soldering work. That's absolutely not true. I'll tell you why. Autofocus depends on two things. You need good light and you need areas of contrast. If you do not have an area of contrast, then autofocus is not going to work properly. If you do not have enough light on the board, then autofocus is not going to work properly. If you are trying to focus on a white paper, there's no contrast on the white paper. Autofocus is going to have a hard time focusing on that paper. Unless you wrote something on that paper and you are trying to focus on the right thing, then you have contrast between black and white, autofocus will work. Let's tilt the board. And autofocus is instantaneous. It takes half a second for focus to work. That's amazing. I mean, I go like this, split second. Okay, let's go like that. Split second. Focus here, focus on the chip, focus on the component. Let's zoom in more. Okay, these are the solder balls on the Samsung board. Look at how crisp the image is. We do not have any reflections. We do not have any light shining back up to the lens. We do not have any glares. We do not have any bright spots, dark spots, nothing like that. You see a clear image, and that's because of the shadow-free ring light. Let's zoom out a bit, okay? The chip. Let's tilt, and now we can read the writings on the chip. Flip the board. Let's look at the FPC connector here. The coils, capacitors. Amazing. Look at how crisp and clear that image is. Nothing shining back, no bright spots, no dark spots, even light all over, and shadow-free light. Let's go ahead and test an Apple motherboard. It's dark in color rather than blue or green. Let's see how it works out under the microscope. I mean, look at the details on this microscope. Let's zoom in on those solder balls here. You see? Focus, instantaneous, split second. Let's look at the FPC connector here. I mean, look at the details on this board. Look at the hair. Look at the dirt. Look at the stuff that you see here. Hello. Look at that. Let's focus on this part. You see how focus is instantaneous? Now, one thing I want to test, or before I do that, let's go over the spotlight. We have a spotlight from Amscope, and it looks something like this. Okay, we can higher the intensity of the light or lower the intensity of the light. Let's go ahead and demonstrate to see if the spotlight makes any difference. If you look at the surrounding of each ball, you have some type of shadow. The spotlight will get rid of that shadow. Let me point the light onto the board. Okay, so the light is on. Let me turn it off. Spotlight off. Spotlight on. Off. On. Let me turn off the ring light and keep the spotlight on. Okay, now we can see the image at a different perspective, maybe because of the way the light is shining on it. We turn the ring light on. Now we have both the ring light and the spotlight, and a combination of both will do wonders. As a lot of you know, when you have flux on a component and you are soldering, reflections can get out of hand. You can get dark areas, dark spots on the board. With the combination of the spotlight and the ring light, we should not have any issues at all, especially that the ring light is a reflection-free device because of the angled LEDs. and the gooseneck is also angled, so we're not going to have any reflections onto the lens. I want to show you an image on the computer, something we took back in the physics class. Light shining down on the board is going to exit at the same angle it's coming down from. So if it's coming down at a 45-degree angle, it's going to exit at a 45-degree angle. Look at the eye on the top. That's the lens. So the lens is not going to be affected by the light that's shining at an angle. And that's the way the ring light works right now. Because light is shining down at an angle, it's going to exit at an angle, and we're not going to get any reflections, flares, or anything like that. Okay, so we have autofocus on. Let's flip the board and maybe look at the back. Let's flip the board and maybe look sideways on the components. Look at that. Look at the chip. Maybe tilt the chip a little bit so we can read the numbers on the chip. And for those who do not like autofocus, you are using autofocus wrong. You have to have enough light on the board, and you have to have areas of contrast. Even that metal piece in the middle, it has some texture to it, so it's not washed out. But if you're trying to focus on something that is washed out, then you're going to have problems focusing. Let me turn the spotlight off. On. Off. You see the sides of every component, how they are dark now? We have shadows casted onto the sides of the components. By turning the spotlight on, now we are able to see the sides of the components. Again, off, on. And that's what the spotlight is good for. Now, one thing I'm worried about is if I want to solder with the autofocus on, I'm thinking maybe autofocus is going to focus on my soldering iron rather than focus on the component. Will that be a problem? Let's go ahead and try it now. Let me turn on my hot tweezers and turn on the soldering iron. And let's go ahead and try to solder with autofocus on. Now, the way autofocus works, if you see on the screen, we have a rectangle. Whatever component falls under that rectangle is the component that's going to be in focus. So now the camera is focused on this part right here. If we move it, now the camera is focused here. Let me zoom out a bit. Okay. If we go like this, now the camera is focused here. 1 second. So, let's say I pull out my soldering iron and I want to solder an SMD component. So right now we are focused on this component here. And let's say I want to solder this component. Look at that. No issues at all. No issues at all. Because the focus rectangle is over the component itself. Now, if I have the focus rectangle over my soldering iron like this, then of course the microscope is going to focus on the soldering iron. But why would I want to do that? I mean, I'm trying to solder this component here. So I place the rectangle over the component, or at least I want the component to be in focus. Or I can actually focus on the other component and work on this component, and my soldering iron is not going to interfere with the autofocus mechanism. So you can work with the autofocus on without any issues. Let me try to desolder a component. Let's say I want to desolder this component here. I'm going to apply some flux. And look at that. Look at how clear the image is. Very minimal reflections. Let's go ahead and desolder this component. It's desoldered. Let's try to solder it back on. And that's it. Let me zoom in more. I am zoomed out a bit. Let me zoom in. And look at the components. Here, look at that. Let's try to unsolder this component. So you see I have my hot tweezers on. It's not interfering with autofocus. So we take it out. And we're going to put it back here. Okay, I really have to have flux on the board, and that's it. So let's try to desolder. Let me add some flux onto this component also and try to desolder maybe this component. Amazing. Image quality is out of this world. Let me see if I can find a BGA chip. Maybe look at the solder balls from under. Huh. Look at that. we can see the solder balls under the chip. Focus on the chip itself, focus on the balls. When you are zoomed in, you have a narrow depth of field, especially when the board is tilted. The board is changing in height, so one end of the board is closer to the lens and one area of the board is further away from the lens. So we're gonna get whatever area is under that rectangular box will be in focus and the rest may not be in focus. Let's put the rectangle right over here. I do not know if you can see the rectangle on the screen, but it's there. Let's zoom in here. Let's zoom in here. I do not see myself turning autofocus off because the autofocus mechanism on this camera is absolutely amazing. It focuses fast. It doesn't interfere with my soldering. And there's no reason why I would turn it off. I do have the option if I'm going to turn it off, but let me turn the ring light off. Okay. We see more texture on the component when the ring light is off. When I have the ring light on and the spotlight on, that's how the image is like. And if we turn the spotlight off, we lose the shadows on the edges of the components. So having both the ring light and the spotlight is an absolute must. I mean, it makes a huge difference, a huge difference. Let's try to have the light off on both the ring light and the spotlight. And that's how the image will be like. And that's when you will start to have problems with focus. If you do not have enough light, then the focus mechanism may start to go out of whack. It's gonna go in and out, in and out. Let me try to focus, for example, on maybe here. Okay, look at that. It's playing on and off, on and off. Okay, not enough light. Let's focus maybe here. If this metal piece does not have texture on it, it's not going to be able to focus, especially that we have low light. I mean, right now it's trying to focus. Let me do something more dramatic, maybe this one here, or maybe some object or some component that doesn't have much texture on it, maybe this here. Look at that. It doesn't know how to focus. There's no light shining on the board. There's no contrast on that component. Very little texture, and the camera is having a hard time focusing. Now, as soon as I turn the ring light on, let me turn the ring light on. I mean, that component does not have any texture to begin with, but with the ring light on, look at that. It's able to focus quickly. So what have we learned from this video? You need a good amount of light on the board if you want the focus mechanism to work fine. You need to have some area of contrast in order for the focus mechanism to work. If you are focusing on a white paper, the autofocus is not going to work properly. You want to focus on something that has a texture. Almost everything on that board has some type of texture on it. So the focusing mechanism is able to focus on anything on that board. You can get ring lights off eBay or Amazon for $20, $30, but they're not going to be the reflection-free ring lights. They're not going to have the LEDs pointed down at an angle. You're going to have reflections, a glare. You're going to have bright spots, dark spots. Do not settle for cheap ring lights. So it is extremely important to buy a reflection-free ring light, and having a spotlight gooseneck is absolutely necessary, because sometimes you may need to have light coming down from the left. Maybe you have shadows on the left. You want to get rid of those shadows. You want to see what's under the shadow, and that's where the gooseneck comes in. By having both the ring light and the spotlight, you cannot go wrong, and you will get nothing but a great image and hassle-free autofocus mechanism. Right now, the working distance that I have under the microscope is 4 fingers. 4 fingers is more than enough. More than enough. You can do anything with 4 fingers work distance. The reason is the ring light is very low profile. It's almost the same size as the lens itself. Maybe it's a 1/4 inch out away from the lens. So it's very low profile. I can easily get a soldering iron under the lens. I can get a hot tweezers under the lens and do my work, and 4 fingers work distance is great. Now, if you put the Barlow lens on and you move the microscope up, then you're not going to be able to use the ring light, because the ring light is only effective if you have it close to the board. You have the angled LEDs. The higher you go, all the angled LEDs will come down on the board as one source of light. So you're going to get reflections, you're going to get flares, you're going to get glares, and you're going to get a weak light, because now the light is at a greater distance up than we have it right now. So if you plan to move the microscope up, then you're not going to be able to use the ring light because the effect of the ring light is not going to work out anymore. It has to be close to the board, and 4 fingers is more than enough to work on any board under this microscope, especially when having this low profile ring light. I saw a few people online where they raised up this same Eakins microscope. They raised it all the way up with the ring light on. You're not going to get the same effect. If the ring light is farther away from the board itself, then the light is going to be weak and you're going to start to have all sorts of reflections because all the LEDs are going to come down on the board as one source of light, and you're not going to have a shadow-free or a reflection-free experience. I do have the Barlow Lens. I did buy the Barlow Lens, but I do not think that I'm going to use it. I do not have a specific reason to use it. If I'm doing inspection only and I want to inspect from farther away, maybe I want to see more of the board under the microscope, then I can use the Barlow Lens. But a lot of things, or most of the things that I do close-ups on components, and this height is just amazing and it's right for me. Let me zoom all the way in to show you how far this lens goes. I have the 180x zoom lens. We are able to focus on the tip of the component. The tip of the component is taking half of the screen, and this is a 201 SMD capacitor. This is more like a 402 capacitor. Look at the texture on the capacitor. The zoom is great. This is the 180x zoom. Let's zoom out a bit. We have a chip here. I'm looking top view at the chip. I'm unable to see the writings on the chip. Maybe I want to read what chip this is. I can simply tilt the board and we can see the writings. Autofocus automatically takes effect. It focuses on the component and we can see the writings on the chip. Right now I have the spotlight on. You see, we can position the spotlight in a way where we can read the component without me having to tilt the board. So the spotlight does have its uses, and that's my review on the Eakins microscope. I really hope you enjoyed it. I will go ahead and link all the stuff I mentioned in this video down in the description. Go ahead and like this video if you liked it. Subscribe if you haven't already done so. Click on that bell next to the subscribe button if you want to be notified when we upload a new video. Leave a comment if you have any questions, and I will see you in the next video.